Question 2 on this week's sheet. You all had a go, so let's go through it and see what you've done and how far you've got. So, you've been given a current that should read 3.2 amps, and it does now on the revised question sheet that I'm going to have up for you by at least Friday. Okay, so you got the current through the 25 ohm resistor, and you've been asked to find the voltage 3,4. That voltage, we're looking for the voltage between these 2 points here and here, and that is because these two components here are in parallel. That voltage is common to both of them. So that's the theory there. So if we find that we're going to use the value of the resistor and the current through it to find the voltage across that component, and then because the capacitor is in parallel with it, we'll have the voltage across that as well. Okay, and because it's per resistance, we're going to end up with a voltage that's got no angle associated with it at this stage as well. Yeah, so what have you done there? I is equal to, sorry, we want E, so that's E1, E34, sorry, is equal to E34, yeah, is equal to IR, which is 3.2 times 25, and the answer you get is, sorry, 80 volts. Okay, so between these terminals we got 80 volts. So we also got, in that case, implied by the parallel circuit, we got 80 volts across the capacitor. Yep.
So the only reason that looks because the resistor's got to angle.
Yeah.
That's why.
If I gave you the current through the capacitor, what you'd have to do is bear in mind you'd then get a voltage at 3,4 that had got an angle associated with it. Yeah, a negative 90-degree angle, wouldn't you? Yeah. Because you'd, unless I gave you a current with an angle, you would anyway. I could give you the current, the complex value, so that you ended up with a voltage at 0 angle, but only one of the two components can be angle 0 anyway. But remember, the angle is what it is relative to something else. So it don't really matter which one is at 0, because the others are all relative to that 0. Alright, I'm not normally going to give, I'm unlikely to give you the current through the capacitor in the exam. Okay, so you've got 80 volts there. Now you've been asked in B to find IC. So how have you done that then? Yeah. So you're doing E34 over XC. Yep. From? Answer?
2.1.
Okay. Reasonably happy so far. C. IL. So you're going IR plus IC, and you're going 3.2 plus 2.1. Okay.
Wrong.
You tell me.
Oh, one of them was an angle to the other. One of them was just a angle.
What else do you know about that? An angle, is there not? Yep. So this should be yep. And that's 0 minus 90. Therefore, what's wrong with that bit? How can I very quickly add 90 degrees to that, Luke? In a flash, how can I add 90 degrees to this? How can I add that 90 degree angle on the capacitor current to that? Hang on, and we are still wrong, because that is not negative. That current, oh hang on, it's a capacitor. Hang on, I'll do it myself. CIVIL. Capacitor. Current leads. Positive angle. We are right. Positive angle, yeah? We're correct. How can I add?
So is that 38 minus 90? 38 minus 90 to give you a positive.
You've got 38 ohms angle
Minus 90.
minus 90 degrees.
Positive.
That gives you a positive 90 degrees there. How can I add? This is here is Kirchhoff's current law. I'll put that. Let's just
Minus J.
minus J, Matt.
IR plus minus J.
By Kirchhoff's current law. IL is IR plus IC, but we can't add them both together till we include that angle. How can I quickly add that 90 degree positive angle? Yep. So it is 3.2 plus 2.1 J amps, and then we can convert that to polar in case we need it in that form. So for the answer to the current here, as soon as you're going to add two values together, you need to ask yourself the question, are either of them complex? Because you can't add together just the magnitudes. Alright? So just be very, very careful. Okay? Part D. What was part D? Voltage across the inductor. which is effectively, we could say that's E23, couldn't we? How do we find that? The formula for it, how have you done it? Notwithstanding you didn't have the right current up until now, but I times XL. It's an inductor, look.
Yes.
Yeah,
3.3. Yeah, 5 times that angle again.
yeah.
So it's been reflected back.
Sorry? That's right. So it should be 3.83 angle 33.3 times, and what was the value of the inductance? 6 ohms. 6 ohms at angle for an inductor. Yeah, 90 degrees. Tom, that arithmetic? I make no apologies. 3.83 times 6, yeah, and these added together, yeah. No, that's plus 33.3.
That's 22.98 or 23 if you want to round it up.
Angle. Yeah. And in there goes some volts, doesn't it? Okay. E. We're looking for the E12, was that?
Yeah.
Yeah. E12. How are we going to find that?
8 minus 3.
Yeah. What we would do, what's the best thing for you to do, is to say, by Kirchhoff's voltage law, yeah, E12 is equal to E23 plus E34. I hope I got that right. So this voltage here, E23 plus E34. Because that's a clockwise arrow. These two are anti-clockwise arrows. Okay, so that's your equation. Agree with that? It's them two added together.
Plus
Yep. Because you,
it's going to lose every time.
yeah, if you go and look at the circuit again, you got to be careful with your theory. Careful with your arrows. This is like the supply end, so it's a strange question because you're working back from the end to the supply. Normally you expect the supply to have the zero angle, but because we work back from this way, we've effectively got this voltage at a zero angle. That one's going to have an angle now. Yeah. If we start at that end, we'd start with that at 0, and we'd have a voltage here that had got an angle associated with it. Okay, you all right with that? So effectively, we're going to add these two together. So the best form to have them in for adding is E34, we know, is 80 volts, angle 0. Therefore, it's just 80 and 0J. Yeah. If we convert this one to rectangular form, you can add, you can do that arithmetic, but it requires you have an understanding of geometry and non-right angle triangles, sine cosine rule, etc. Long-winded. Because your calculator will add polar values, will it? I'd sort of be expecting you to show me that you know what you're doing, yeah. Yeah, alright. So let's convert this one to rectangular. Yeah, you get minus 12.5 plus 19.3 J. Yeah, I'll go with that. Okay, so now we can carry on with this arithmetic. What I tend to do with questions now is that if I end up with a polar answer, I just calculate the rectangular answer and write it beside as well, knowing I may well need it later, type of thing. So E12 equals 80 plus, sorry, minus 12.5 plus 19.3 J. 80 minus 12.5 is 7.5 plus 19.3 J. That is volts, but we'd really prefer to have that in polar form. Angle 16.03. There we go.